Thank you very much for the introduction. So, as you may have seen this summer, more specifically end of July, beginning of August, big tech stocks plunged, and it was most likely due to disappointingly low revenue from AI. You can see this article from Fortune talking about the AI bubble, which is responsible for a 25% drop. Others from The Guardian, and many other articles. And indeed, LLM-based products often do not make it to production or gain few user adoptions. And if you have no or few users, you have a low usage. Hence, the AI providers providing the services make low revenue, and which links it to the previous slide. And the main reasons for that are that first, user value is not well addressed. Since we are in a bubble, a lot of people want to do GenAI to raise funds, just to say it on social medias, and it often leads to questionable value. And the other reason is that the performance is often not good enough of what people build with GenAI. And because we are dealing with a lot of new tools and methods, we need to find out the best practices to build with them. So what is the best life cycle to build with them? And this is the subject of today's talk. So we won't focus on user value, which is also very important, but really on the performance part. The learning objectives for today are first, the importance to understand the importance of a good data methodology to build performant products. We will dive in a real-world efficiency problem we have to solve to put everything we explain in practice. We see the best practices to build evaluation datasets, when and how to use LLM as a judge against manual evaluation, and why using an LLM monitoring tool like Longfuse. So about myself, thank you for the quick introduction. But so I'm engineering manager and a GenAI lead, and I work at Theodo, the data AI part of Theodo, which is a service company building data science and data engineering products for their clients. I've been working in the field for the past 5 years and worked on various projects like OCR, predictive maintenance, and more recently RAG, LLM, and stuff like this. And I've been a speaker at many international conferences. So about today's topic, so a few years ago, NLP, the big boom, like let's say 5-10 years ago, more like 5 years ago, and people start building a lot of stuff like sentiment analysis, document classification, or entity recognition. And over the years, people, the community, they established the AI development lifecycle as the best practice to go to production, because a lot of products were not making it to production. And they feel that with these good practices, products were more likely to go to production. So first, you plan what you want to do, you prepare your data, you engineer a model, you evaluate it, deploy it, operate it, and monitor it in production. And you're good. And then ChatGPT and LLMs arise. And the massive change people noticed is that when building products, getting first decent results it was much faster with LLMs than with traditional NLP. And since it was very easy to build stuff very fast, we saw a lot of videos like this where people were explaining how to build a product like chatbot in a few minutes. Hours. So how does that affect the development lifecycle? What really changed? Actually, nothing. The steps are the same, because even though we are not training a model anymore, very often you can still fine tune, but very often you can just call APIs like the one of OpenAI's. We still need to prepare a data set for evaluation to evaluate our task. We still need to engineer a model, whether it's a RAG, a prompt, and agents. You often need to add materials as well for your use case. You need to evaluate what you're doing to make sure when you're iterating in the right direction. You still need to deploy an application. Even though you're using APIs, you need to deploy something around it. And you still need to monitor the usage, the data drift for continuous improvement. So while getting decent results is much faster, it's actually the opposite for good practices. Because first, since you do a lot of free generation, before with NLP, you were just expecting a 1 or a 0 very often. Here you have like an unlimited number of possible answers, so it requires a lot of manual evaluation. And moreover, there is a lot of new tooling and methods which are not yet mature and can be a bit complicated to use. So since we all love getting shining things quickly, when people see that it's very fast to get first good results, they want to do that. They want to build this kind of chatbot in 10 minutes. And when they see good practices are very hard to set up, they often fade away. Hence, one of the big problems, like linking with the introduction on the stocks which plunged due to bad performance, it's often linked to these 3 steps of the life cycle being neglected. So the 3 steps are the data preparation, the model evaluation, and the monitoring. And the impact of a bad evaluation is that you do pointless iterations. If you don't evaluate well, you may notice improvement on some results, but no generalization. You have no knowledge of the product performance, so the team don't know if it's good enough to go to production and can't really convince the stakeholders. And the impact of a bad monitoring is that you have a lack of knowledge on how users interact with the tools, and lack of visibility on potential data drifts from the test inputs to the real inputs. And as a result, products will struggle to gain adoption in production. So now to illustrate this, we are going to walk through a typical use case using LLMs. So it's a use case involving text to SQL, and basically this question of documentation in a SQL database. So it involves retrieval methods, text to SQL methods, and LLM. And we are basically going to detail for this use case the 3 steps which we just pointed out as being very important. So data preparation, model evaluation, and monitoring and evaluation. So to explain a bit more the use case, IQVIA, which is a medical company, they have clients which are pharmacies, and these clients, they come with a broad question on a certain type of drug, for instance, because they want to build a new drug based on the same molecule, or they want to know how similar drugs are doing in terms of reimbursement, legalization, etc. So they come with this broad question to the consultants, which belongs to IQVIA, and the consultants query a large database which contains drug data for every country and over 2 million documents. Each document is very long, to basically write a report on how what the drug is, etc., etc. And it comes with 2 efficiency problems. The first one is that the client, the pharmaceutical company, they could want to query directly this big database, but they have no technical knowledge on how to do it. They don't know the data schema, etc. And the consultant, it takes them actually days to weeks to find and write the good information, because it can involve many documents with tens to hundreds of pages. So to solve this problem, we built this high-level solution, which involved a user formulating a query. The query is transformed to an SQL to a SQL query, so natural language queries to a SQL language query. And then from the documents retrieved, an answer is provided to the users. Sometimes, even after many retries, etc., we cannot find any working SQL query, so we just do semantic retrieval as fallback. And then the user can keep chatting or ask for a document summary. When they ask for a summary, they mostly want to highlight the reasons for or against the legislation or recommendation of a drug. And since they have a very specific intent and expect a specific format, it basically goes to a specific pipeline. And the AI tools we are using for this are mostly OpenAI, Azure AI Search for the retrieval, and Longfuse for monitoring. So how did we do for the data preparation? So we want to build an evaluation dataset, and we are doing this while doing the user interviews. Because before building the product, we have some convictions on how the product should be, and we want to validate it with the users. So we go to each users, and when they tell us how they would use the tool or how they are doing their research currently, it helps us to build a data set of 100 questions labeled with expected outputs, and working with the consultants, building 10 example summaries to know what we are aiming for. And these examples include small variations because the users, they may do typos or stuff like this. They may not write exactly the same word that is in the SQL database. So we need to, from the beginning, be able to take into account these variations to measure the actual performance of the product, and do some slices classification to ease evaluation. Actually, clarifying the data sets enables to clarify the product. It's not just to measure performance, it's really to help the product conception. Because first, it helps to clarify the scope of the project. How should we actually build the tech? Should we do fleet generation, classification of sentences? On another project, this is an example of what it's relevant. We were given a transcript of interview, and we had to provide to the person doing the interview 3 new questions to ask. First, we wanted to do fleet generation, so just feed an LLM with the transcript of the interview and just say, all right, just provide 3 new questions. But during the interview, we realized there were roughly 20 possible questions to ask. So there is actually no need for fleet generation, which can lead to a lot of edge cases and it's hard to converge. Given a transcript, we can just restrict the output of the LLM to be among these 20 possible outputs. So just do a classification. Which data do we need? Again, and another example on another project where the client who wanted to ingest, who wanted to do a RAG, so question over documentation, and they wanted to ingest many heterogeneous sources, which will make the project much harder in terms of time to ingest the sources, but also performance. And collecting these data sets by asking the users, we realized all the questions could be answered with the same 2 sources. So it made the product much easier from the beginning. It also helps to prioritize. Let's say you see that 90% of the collected questions are on topic A. You know this is where you need to put all your effort at first. And secondly, clarifying the data set helps to prevent endless iteration. Here, for instance, for the summary, one way to build this summary, so we have to build summary of the drug documents. It could be just to ask the LM to put a summary and then ask the business person to say if it's correct. But then they will come back with some feedback, so we correct it, and they come back with feedback again. And what we realize is that doing so, it leads to endless iterations because it's always, oh, it should be a bit less wordy, oh, and that as well. So just writing up from the beginning 3 perfect examples, it helps to set up straight away what are the expectations and to not go back and forth all the time. Regarding the model evaluation, so we had basically two ways to evaluate the end results. So the answer generated by the LLMs. The first one was manual evaluation. So we just look at all the answers at every iteration and say if they are correct or not. And the second one is LLM as a judge with labels. It basically consists in giving all the answers provided by the LLMs to another LLM or the same one with the perfect answer and basically asking, all right, is the answer you provided here the same as this perfect answer? To put it simple. Basically, doing manual evaluation, the pros are it's very reliable, and it will make you look a lot at your data, so better understand your data, better understand your model behavior. So it's super useful at the beginning where you want to really understand it a lot as a technical person. But it's very expensive because it takes a lot of time, and it limits the number of iterations and the number of examples you can look at. But doing judge, the pros are it allows to do automatic metrics, like compute metrics automatically on thousands of examples. But it's an extra logic to maintain, because when you will change your prompts, you may, like in your project, etc., you may have to change your evaluation prompts as well. So it doubles the work. It's hard to be accurate on complex examples, as we'll see in a bit. And since we are doing an evaluation pipeline with AI, you kind of need to evaluate the evaluation pipeline, and you can see how it can go wrong quickly. So our conclusion, building with LLM as a judge, was first, it has a lot of bias. Because let's say you are comparing two different LLMs and using GPT to compare GPT and Gemini, let's say, GPT will tend to prefer GPT. Although the order you put the example in, let's say you put first your predicted answer and then the perfect one, or the other way around, it will give different results. Moreover, since we are using GPT to evaluate, which is a closed source LLM, every time we run it, it may run on a different GPU in OpenAI's data centers. And since different GPU won't give the same results, two inferences may not give the same results. So this non-determinism was a problem as well. Because sometimes an evaluation will say it's okay, and afterwards it will say no, it's not okay. But it works well on easy questions. Let's say your question is 1 + 1 = 2. Although you have all this non-determinism, order that matters, etc., the answer is so easy to check for the LLM that it will 99.99999% of the time be correct. So it's quite good to check easy questions, which are where the answer is easy to verify. However, it kind of becomes a meta project on complex tasks. So on the summaries, since the summaries where we had to put bullet points, so what happens when you put more bullet points in your predicted, in your generated answer than in the predicted one, what happened when they overlap, etc. So it makes it very complicated. We had to evaluate the performance of this judge, so it kind of becomes a meta project, and it's kind of not worth it. And the last conclusion we had is that you can actually improve your judge through manual evaluation. So you're doing so when iterating on easy question, because it's where we used it, you can do an iteration of the judge. You want to make sure your judge is working okay, so you do a pass of manual evaluation, and comparing the differences of what your judge outputted and what your manual evaluation did, you can actually update your prompt, being like, all right, here it did not work well, here it worked well, etc. So take this edge case into account, etc., etc. And we rely mostly on manual evaluation and evaluated simple questions with LLM as a judge. To finish on manual evaluation, just want to say that, like, since we are using closed source LLMs, evaluating can be tough because 2 runs may give two different results. So you just, as I just said, because of the non-determinism, so you just run your pipeline twice, not the evaluation pipeline, but your real pipeline, and it gives 2 different results. So it's not a problem when you have like 40% of good answers, because when you have 30% of good answers, usually you do like big steps of improvement. You improve 10% by 10%, and the increment is widely above the uncertainty bias. But when you reach around 90% of correct answers, you usually work with small increments. So you want to improve your pipeline percent by percent, and 1% of improvements is within the uncertainty bias. So it's very hard to know if when you have 90% and then on the next iteration you have 91%, is it due to an actual improvement, or is it just bias due to the non-determinism of the LLM? So what we did to overcome that is, so for the easy question, because we reached 90% of correct answers on the easy ones, we use LLM as a judge to get an average over 5 runs. So we were running our pipeline five times, sorry, and evaluating it 5 times to get a kind of average. And also we clarified the prompts to avoid confusion, because a problem we had was that since we were iterating a lot on the prompts, etc., some prompts may contain different, like within the same prompt, you may have different instructions which go at the opposite of each other. So so sometimes when you run the LLM, it will follow the first instruction. Sometimes it will follow the other instruction. So just by clarifying the prompts, it helps with this non-determinism. Finally, on monitoring, so we use Longfuse. Longfuse is an open source tool to monitor and analyze our production usage. So on Longfuse, you can see basically all the tokens you used and the cost it had for a single run, which is very helpful to monitor costs. You can also see the average on all runs. Here you can see the question we asked, the SQL query generated, the final answer generated, and all the thinking process of the LLM. So it really helps, really is the evaluation of the LLMs. So sorry, I talked about evaluation, but here it's more for monitoring. So monitoring in production the end users' usage. So what changed in the development lifecycle from traditional NLP to LLMs? Nothing when considering the macro steps, a lot when digging into each step. And to finish, this is my go-to stack to implement these best practices along the life cycle. So for data preparation, I just use Google Sheets because I don't need anything fancy to just collect data. And the advantage of Google Sheet is that it's not technical, so you can very easily share it to business users, which will help you collect this data set and label it. For model engineering, I use DVC, which is kind of Git, but for data, which help monitoring the experiments, etc., etc. I won't dive too much into this tool here. For model evaluation, I still use Google Sheet for manual evaluation and organize my data in Notion. This is quite disappointing because this is not ideal at all. But to my knowledge, I have not found any great tool to store, classify, and comment results, and also do manual evaluation. Because I know there are a lot of tools over there, like Ragas, Promptfoo, etc. There are a lot of tools, but none of them made it like met my needs for that, which were quite easy to be fair. They all want to do like very fancy stuff, which is not what I need. And to analyze the results, I use Streamlit. For model deployments, if I use an open source model, I will use VLLM to deploy the open source model, or Laminae, which is a closed source version, so more managed, less work to do. and any other service to deploy and register containers to deploy the product around it. And for monitoring, any of the following tools. So these are the free tools I use: Longfuse, Longmist, Literal AI. They pretty much all do the same thing. They're also very cool because they help to replay prompts to include business users in prompt iterations, which is very useful. So this is, for me, the monitoring tool with LLMs is really the best tooling which has come out so far. This is everything. Thank you very much for listening to me. So do not hesitate to reach me on LinkedIn, or this is my website if you want to have a look at all the talks I did so far. Do you have any questions? Maybe I can go on the so if you have any question, do not hesitate to put it in the channel. I can send you the link. Maybe I don't know if I can share a link.
I shared the link in the chat, so please feel free to ask any questions you have. We still have a few minutes.
So thank you, Robert, for your question. You can use MLflow to record experiments and compare metrics, right? Yes, but you cannot do manual evaluation on MLflow. And then update, to my knowledge at least, updating an experiment with manually on MLflow to make it easy is not quite possible. Can you share the slide in the chat? Yes, I say. Does that answer your question, Robert? I can share the slide in the chat. And yeah, the other problem I had using MLflow, Robert, is that because I used it a while ago, but not for LLMs, is that when you run too many experiments, you often have a board fully loaded of like millions of experiments. And just for good tracking and to help other teams which will take over understand it, it's not ideal. You want to be able to hide some, to command them, etc. And it wasn't perfect for me. So at the end, I always use when I use the MLflow, I use Notion on top of MLflow to highlight the most important experiments and explain next to them like the reasoning process, why I did them, what was the result, what was the analysis, showing some pictures of